Tekken 5.
Dive into Python with a fun game, learn in just 5 minutes.
Ever wondered how to make a game character run? Follow me. By the end of this video, you'll learn how to do it. Welcome back, fellow coders. Last time we defied gravity together, giving our character the power to leap with a simple press of a key. Today, we're bringing a new sense of dynamism to our game. Get ready to hit the ground running, as we bring our character's movements to life with a smooth, realistic running animation. First, let's take a look at the draw method of the player class. With a few lines of code, we turn simple geometric shapes into a stick figure. A circle forms the head, while straight lines piece together a body, arms, and legs. It's a minimalist yet expressive character. Next, let's understand walk cycle. Every step in a walk cycle has 4 essential phases. The contact phase is where the foot first hits the ground. Next is the down phase, where the weight of the body presses down, and the knee is at its most bent. The passing phase is the midpoint, as the rear leg swings forward. Finally, the up phase raises the body to its highest point, as the leg prepares for the next contact. These phases combine to create the fluid motion of walking. In our code, run state dictates our stick figure's current walking pose. A timer ticks every frame, cycling through poses every 10th frame to animate a seamless walk. This loop gives the illusion of continuous motion. In our game's engine, the draw methods are the core component for our stick figure's appearance. The draw circle method is our tool for sketching the head and hands. It paints a black bordered circle, then overlays a slightly smaller white one, crafting a crisp, cartoonish look. Then there's the drawline method, the backbone of our figure's limbs. It's a study in geometry, translating angles and lengths into the endpoints of lines that represent arms and legs. It's here that trigonometry meets art, as we calculate the x and y coordinates from the given angle, creating a line that extends from the start point in the direction we dictate. For the arms, draw arm uses draw line twice to form each arm, once for the upper arm to the elbow, then again for the forearm to the hand, finishing with a small circle for the hand. Similarly, draw leg uses the same approach to articulate the legs. We first draw from the hip to the knee, and then from the knee to the foot, with a final short line to represent the foot itself. In the heart of our stick figure's animation lies the draw method, a symphony of lines and circles that culminate in a walking motion. It begins with the head, drawn as a circle, perched atop a line that forms the body. But the true magic unfolds in the limbs, articulated in distinct states of a walk cycle. In the contact phase, our first state, the arms and legs are positioned to mimic the moment one foot strikes the ground, propelling the figure forward. Here, we use calculated angles to bend the arms and legs, creating a sense of motion. One arm extends forward, while the other reaches back, complementing the stride of the legs. The leading leg is slightly bent at the knee, while the trailing leg extends, ready for the next step. The subsequent states, down, passing, and up, follow a similar pattern, each capturing a snapshot in the cycle of walking. We adjust the angles of the limbs to reflect the natural motion of walking, providing a dynamic visual rhythm that brings our stick figure to life on the screen. In our game, the background class is ingeniously designed to create a dynamic and visually appealing environment. This class manages a series of trees that simulate a scrolling background. The Generate Trees method initializes our scenery. Here, we strategically place each tree along the width of the screen. The positioning isn't uniform. Each tree is spaced randomly. Using Python's random method, it ensures that no 2 stretches of our game's background look exactly the same. The Update method brings our forest to life. As the game progresses, each tree shifts to the left, mimicking the player's forward movement, and when a tree exits the screen stage left, it re-enters stage right, given a new random position. Finally, the draw method is where we visually construct each tree. We render the trunk as a simple line and the canopy as a triangle, defined by 3 vertices for a stylized, minimalist tree. From simple shapes to a running hero, we've journeyed through Python's creative power. Until next time, keep coding and exploring.
Stay tuned for more videos on Tekken 5.